Hey, welcome back to your favorite fundamentals of college math class. Let's take a look at some properties of circles. Of course, we got the center of the circle, and a circle is just made up of all points that are equal distance from that center, right? That will create your circle. The distance around it, of course, is our circumference. What's that length around it? From the center out to the circle would just be our radius. Double the radius is our diameter. 2r makes up our diameter, r plus r, 2r. So let's go ahead and find the diameter if you're given the radius. Well, if the radius is 7 inches, then all the way across would be 7 plus 7. So we would just have 14 inches, of course, right? If you're given a diameter, all the way across is 36. Half of that would just be a radius of 18 inches, would be half of 36, right? All right, what about the circumference? Well, there's two formulas for the circumference. You can either have pi times the diameter, but remember the diameter is 2r. So you could have 2r times pi, or 2 pi r for the circumference. And here it looks like we're given a radius of 7 inches, so I'm going to use the circumference that has the radius in it, 2 pi times our radius. So we have 2 times pi times our radius, which is 7 inches. So we got 2 times 7, 14 pi inches. And then I would go ahead and use my pi button on my calculator. So 14 times 3.14159, blah, 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 right? Use that pi button on your scientific. You'll end up with 43.98229.715, or approximately 43.98 inches is that distance around. Now, what about the area of a circle? Like, in other words, how much paint does it take to paint that circle? Well, the area is pi times the radius squared, and it looks like our radius here is 3 feet. So 3 times 3, 9 pi square feet will be our area. In other words, if I use my pi button again, 9 times 3.14159, and so on, will give a 28.2743338. So about, let's say I rounded to the nearest tenth. So I look to the right of the 2, I got a 7, so I'll bump that up. Square feet. So I want you guys to go ahead and try this one. You've got a circle with a radius of 8. Find its area and its circumference if you've got a circle with a radius of 8 inches. If you're finding your circumference here, we're going to put in the 2 pi, and I'm going to use the radius here is 8 inches. So you end up with 16 pi inches, and then I go ahead and I punch in the 16 pi, and I'll get 50.26548.246 inches. And you can round that, let's round it to the nearest tenth where that 2 is. So the 6 to the right of it will bump that up. So about 50.3 inches. And then the area, pi, my area here is 8 inches square. So it looks like I got 8 squared. 8 times 8, 64 pi square inches. Same thing on this one. Go ahead and punch that in, and you'll get 201.0619298 square inches, or approximately 201.1. Again, if I'm doing it to the nearest tenth, I look to the right, and it's a 6. If it's 5 or above, right, it'll bump that up. So 201.1. All right, let's take a look at perimeter area of some composite figures. So something that's not a standard polygon. And so when you get some complex shapes and things, you may have to kind of split them up a little bit, create regions, so you can find the area and then add the areas together. But let's go ahead and start with the perimeter on this first one here. So perimeter, we're just going to add up all the sides, right? So I got 18 plus 6 plus 3 plus the 11 plus the 9.5 plus 6 plus 6. All right, so we add up all the sides. 18 plus 6 plus 3 plus 11 plus 9.5 plus 6 plus 6. So our perimeter ends up being 59.5 centimeters on this, okay? So that's the perimeter around this composite figure. Now the area is going to be a little bit different. What I'm going to do is I'm going to split this up into region A. Let me kind of cut this off a little bit. And you see how I have a rectangle right there? And then let me call this one region B. So I'm going to, this total area is region A plus region B. And so this area will end up being, well, I know the area of a rectangle is length times width, right? Or base times height. So I'm going to go, that rectangle, whoops, is 18 centimeters times 6 centimeters. Plus, now I've got a triangle on this other one. So I know a triangle is 1/2 base. So my base is right here in blue. That's the base. Oops. So I got to figure that out. Well, notice the whole top side is 18, right? So 18 minus 6 and minus 3. If I subtract those parts out, 18 minus 9, I'm left with 9 centimeters right there. I know the whole way across is 18, right? So now I've got my base, 9 centimeters. And now what's the height of the triangle? Notice it shows us the height there. It's giving us that 9 centimeters right there. The height of that triangle is 9 centimeters as well. All right. So let's go ahead and punch it all in now. I've got an area, 18 times 6 is 108 square centimeters. 9 times 9 is 81, so half of 81 is 81 over 2, or 40.5, same thing, square centimeters. So I've got 108 plus 40.5, I've got 148.5 square centimeters. That's that total area if I were to paint all this, right? Paint that area A and B. Second example, looks like Rosie, we got planting a garden with the dimensions shown below. She wants to put a thin, even layer of mulch over the entire surface area. The mulch costs that much per square foot. How much is she going to have to spend? So we need to know the area of this, right? We need to know how many square feet we have here. And then we can figure out the total cost from that, because I know it's $3 for every square foot. So let's find out how much total square footage we have. So I'm going to split this up again. Why don't we split this into a rectangle? I'll call that, how about area 1, that rectangle? And then I'll call this area 2. I've got a trapezoid down there. Okay, so I've got this total area would be area 1, which is the rectangle, plus area 2 being the trapezoid. So area 1 would be base times height, or length times width. There's that top rectangle, length times the width, right? So I got 32 square feet from that. But over here I've got this trapezoid. Let me do that in blue, this area 2. So 1/2 h base 1 plus base 2. Base 1 and base 2 are the parallel sides of this. And I know base 1 on the top is 8 feet. Right, that's 8 feet. And then on the bottom, it looks like I got 14 feet. And then my height, they give to me is 4 feet. So let's punch those in. So there's my rectangle. I got 1/2. My height here is 4 feet in red. My base 1 is 8 feet plus the bottom base 14 feet. So we got 32 square feet plus half of 4 is 2. And then 8 plus 14, I got 22 feet. So I got 32 square feet plus 44 square feet. It looks like this whole area that I need to cover in mulch is 76 square feet I got to cover, right? So what would the cost be after after I found my total area? And what's my cost? Well, the cost is I have 76 square feet I got to cover. And I know it's $3 per square foot. Notice my square feet's canceled. So 76 times 3, which ends up being a cost. If I punch that into my calculator, I'll get $228 to cover that area in mulch. All right, this next one's a you try it problem. So go ahead and try this next one. Whoops, I keep moving now. That's not supposed to move on me. Go ahead and you try this next one. Here's your little check on that you try problem. You're just adding up all the sides for that perimeter. All right, so you got 2 plus the 9 plus the 7.3 plus the 2. There's your 20.3. And then I split it up into a square and a triangle. And notice the base of this triangle, though, is only from here to there. But all the way across is 9. So I have to go 9 minus 2. That gives me this spot as 7. From there to there. That's my base of that triangle. Right? It's 7. So 1/2 base times height. And, of course, the height there is 2 feet, the same as that far left side. So if I'm thinking about the perimeter of this is kind of interesting because it goes... I got this 8 feet, I got this 20 feet. You know, the question though is how far is it around that? And that's half of a circle. Well, what's the distance around a circle called? Circumference, exactly. So I have this 8 feet, I got the 20 feet, which is, let me do that in blue. Here's the 20 feet. I got another 20 feet down low, right? So this perimeter is 8 plus 20 plus 20. And then in red, it's a half of a, it's not the whole way around a circle, it's only half of it. So a half of the circumference. So 8 plus 20, I got 48 feet plus 1/2. Now our circumference. Remember our circumference is 2 pi times the radius, or you can do pi times the diameter, either of those, right? But it looks like it gives us this diameter. The diameter all the way across is 8 feet. So I know my diameter. So it's a 1/2 pi times the diameter of 8 feet. So it looks like I got 48 feet plus 8 pi divided by 2 is a 4 pi feet. So I punch that in, I get 60.5663761 feet. Of course, I could round that if I want to. Finding this perimeter again. This would be a good you try it problem, by the way. Our perimeter here would be 1 plus 1 inch, plus another inch. And then we've got, instead of the whole way around a circle, we just a half a circle, right? We know all the way around circumference is 2 pi r, right? All the way around a circle. Our circumference is 2 pi r, or pi times the diameter. And it looks like they give us the diameter. They give us the diameter all the way across. So I'm going to use a half of my circumference. So we got 1 plus 1 plus a half my circumference. My circumference is pi times the diameter, right? My diameter here is in red 1 inch. So it looks like I got 1 plus 1. I got 2 plus 1/2 times pi times 1. So we got 2 plus pi times 1 is pi. Half of pi is pi over 2. So I'm going to punch that in. 2 plus, use that pi button, divided by 2. And that'll be like 1.57079 type of deal. So plus 2 would be 3.570796327 inches. And that's all the way around, right? The 3 blue areas added up. All right, let's do another composite. What about if we've got 3/4 of a circle and a square, but they want the area this time. We want the area. So let's do this as area 1, and that would be in red. All this in red. Okay, so 3/4 of a circle. And then let me do in green area 2, which is that area, that little square. So the total area is area 1 plus area 2. And area 1 is 3/4 of the area of the circle. All right, it's only 3/4 of it. And then this is the area of the square. Well, we know the area of a circle is pi r squared, pi radius squared. What's our radius? Looks like they give us it's 2 feet. So I'm going to plug 2 feet in right there for the radius. Let's also do our area of this square over here. Oops. Which would be base times height, or side times side. So 2 feet times another 2 feet would be the area of that square, so 4 square feet. So we got 3/4 times pi. My radius here is 2 feet squared. So 2 squared is 4. So I got 3/4 times 4 pi. I could put that over 1, see how my 4's cancel. I end up with 3 pi here. And over here I got 4 times 4, 4 square feet. So my total area is 3 pi plus 4. So 3 pi is like 9.42 something. And then plus 4, this will end up being 13.424777796 square feet. Or about 13. Let's do the perimeter on this first. So let's say we've got, so it looks like I have a half a circumference there and another half a circumference there. Let me call that circumference 1, half a circumference 2. So this perimeter is that half a circumference, that other half a circumference, right, which is the same amount. And then this side, which is 6 inches, and that side, which is 6 inches. Well, these two circumferences together will make a full circumference, right? So 2 pi times the radius, or pi times the diameter. And then 6 is 12, right? Because we know our diameter here all the way across this is 6. So I got pi times 6 inches plus the 12 inches. So I got 6 pi plus 12 is my perimeter, or 18.85 plus 12, so 30.85 inches. There's my perimeter of this. Okay. Now let's talk about area for a second. Let me erase this. And I can leave that. I'll leave that. My area would be area 1 plus area 2. Those are both half circles. So this total area, area 1 plus area 2, right? Both of them are half of a circle. So together they're going to be one full area, right? One full area. And then the area of the square, I'm going to call that area 3. That's area 3, area of the square, right? So we've got the total area, area 1 plus area 2 is the area of a circle, a full circle, plus area of the square. So this total area, we know the area of a circle is pi times radius squared. Well, all the way across is 6 inches, so what's just the radius of this? Just be 3 inches, right? So pi times 3 inches squared. That's the radius, or that's the area of the circle. Now the area of the square is base times height. 6 inches, one side length times the other side length. So I got a 36 square inch for the area of the square. Now 3 times 3, 9 pi square inches plus 36 square inches. That gives us a total area of 64.27 square inches. All right, let's get into volume. You know, we've been working in a two-dimensional world, but it'd be nice to do some mathematics in 3 dimensions, right? The world we live in here. So here's some basic 3-dimensional figures. You've got a cube where all the side lengths are the same. You've got a rectangular prism as that second one. One's just shown solid as if it's painted. The other one's just a transparent. And then we've got a pyramid, right? Like the Great Pyramids of Giza or the Luxor, right? This pyramid for those living here in Las Vegas. And we've got a cylinder, where we've got a circular base on both ends, top and bottom. We got a cone where we've got a base of a circle, but they meet at one point at the top, right? That'd be a cone. And then we've got a sphere, right? And so if we're finding volume, which is like if we were to fill it all up with water, right? That would be like how much volume in water we'd have. You can think about that. We're going to do that in like cubic units, right? Like if each of these are 1 inch, then for this cube, length times width times height, and each of these are in inches, this volume of each of these little cubes would be 1 times 1 times 1 is 1 cubic inch, right? And so I'm adding up how many of these cubic inches do I have? 1, 2, 3, 4, 5, 6 behind it, 7, 8, 9. Anyways, I add them all up, right? And how many it fills up is how many cubic inches I have in that shape, right? That's my volume. So I can measure it in cubic. And so here's some formulas for a cube: length times width times height, right? And again, my units are always cubic units. There's my rectangular prism. There it is for a pyramid. It's a third, length times width times height. That's for a pyramid, where you get that rectangular base on the bottom, right? You got a cylinder, which is pi r squared. The area of the circle on the bottom, right, is pi r squared times that height. That would be the area of a cylinder. Cone, I've got a third pi r squared h, and then finally a sphere, 4/3 pi r cubed. So we'll refer back to these when we're finding these volumes. Let's go ahead and do it for this first one here. It looks like I've got a pyramid. All right. And so I would go ahead and I would reference this above. I know the pyramid volume is 1/3 length times width times height. Here's my length, here's my width, there's my height. So it's a third length times width times height. Notice I have a rectangular base on the bottom, right? So let's go ahead and punch that in. 4 inches my length, 3 inches my width, and then the height. And the height note here is from the top straight down, and it makes a 90 degree. It makes an altitude, if you will, with that base. It makes a 90-degree angle with the base. That's what your height is. And of course, it's 8 inches as shown, right? And so 1/3, let's see, I got a third. 4 times 3 is 12. Well, let me cancel these 3's. There we go. And so I have 32 inches times inches times inches is cubic inches. So I would have 32 cubic inches if I was to fill this up with water or whatever, right? That's how much volume I have for that. All right, this next one looks like we got a cylinder. It's not a very tall cylinder, but see the circular base there. So the volume of a cylinder is the area of the base, which is pi r squared times its height. And notice it gives us that radius. So our radius here is 7 feet, it's squared, and then our height here is just a height of 1 foot. It's not very tall, looks like. So we got pi, 7 times 7, 49 pi, 49 times 1 is 49, so I got 49 pi square feet times another set of feet is cubic feet. Remember, you're always in cubic units cubed for volume, right? It's always your units cubed. And then I just use my pi button again, and you'll end up with 153.93804. Let's round it. It looks like it says round it to the nearest hundredth. That's where that 3 is. That's the 100th position, the second position there. So I look to the right of the 3, and it's an 8. So it'll bump that up, right? That'll bump that up. So I got 153.94 approximately cubic feet. And then our next one here, we've got a eutriot problem. You've got a sphere. I could draw a sphere as best I can. You've got a radius it's given you of 6 feet. So go ahead and use your volume of a sphere formula and try that. So here's the work on the rest of that. You guys just make sure you punch in your radius on this, which is 6 feet. Of course, 6 times 6 times 6 is your 216. 216 divided by 3 will give you that 72, right? Or however you want to punch that in. But you get 288 pi, and then use your pi button. Thanks so much for watching, and see you next time.